Okay, so here we are. We're starting part three, which is really about the reconditioner itself. So let me go to the next slide. My PowerPoint's going weird. There we go. Okay. So this slide here kind of shows where the EVCs are located around the world. This map is actually available on our website, and I constantly update it. This map's actually a little bit old. We have over 100 EVC units now. And we're still found in over 13 countries. Majority of those are in the U.S. And actually a lot of the instruments that are more international are starting to have been within the last year or two. But again, we developed the instrument back in 2014, 2015. So all of these this technology is still somewhat new, but it's growing in many places. Okay. And over 300,000 modules have been reconditioned. So it's over 250,000. But there are, I think I did this calculation before, there's something like tens of millions of modules out there, currently in vehicles and all the replace. So the market is definitely still growing. Actually, Toyota is still using nickel metal hydride modules in a lot of their hybrids. Some like the plugins have kind of transitioned to the lithium ion, but a lot of the lithium ion batteries are starting to get some trouble also. So nickel metal hydride batteries aren't really going away soon. All right, so here is the EVC30 kind of front panel. I just want to show you what it looks like. You have the power button up to the top left. This right here is the battery connect disconnect. It's basically, if you press it in, it will shut off all of the channels. It will stop the control, but it will still read voltage and such. These lights, the charge and discharge lights, these aren't buttons, these are lights, but they're useful because it'll show you if you're across the room, kind of what step your instrument is on. You have a USB connection that goes to a laptop. And in the EVC30, you have 30 channel inputs, okay, with 30 cables. And the power of the instrument it requires a 220 volt plug. And again, a lot of our international customers, we can adapt the plug to fit your electrical requirements. Yeah, in the US though, you want to make sure that you have a proper L630 receptacle that is a 220 volts. And I kind of showed, this was before because I wanted to show a previous customer to make sure that they had the correct electrical outlet. But that is just for you to note. And what is included? So you have the laptop, you have the cooling box. Okay, we also include the fan, and I'll show you that in the next slide. A QR code reader. So this is useful because every single module has a specific QR code to it. Okay, and that QR code will actually tell you when that module was manufactured. So what's important is to use the QR code reader to scan your modules when they're in your inventory. The most important thing is that those QR codes cannot be taken off. So if you use some type of sticker or some other way to keep track of your modules, which I also recommend, the QR code, note that it is not removable. Okay. You also need a adjustable torque drill, and this is to connect the cables, the EVC30 cables, to the terminals. All right. Within the terminals, you want to use 50 inch-pounds. Okay. That's our recommendation because if you go too much torque, you can actually damage the terminals. I had an intern that was doing research with us, and he bolted the nuts on so hard that it just popped the terminals out when you try to remove it. So be careful of that. Also, when you get the instrument, you need to make sure that you have Wi-Fi because it comes with help setting up. So I will help you set up and run your first, pack or two. But remember to keep the Wi-Fi off when you're not using it, because remember the EVc30, it runs for about 20 to 24 hours. So it runs overnight. So you need to keep the laptop plugged in and on, and not falling asleep, the laptop falling asleep. But keeping the Wi-Fi off will prevent Windows from updating it, because sometimes Windows sends automatic updates and it automatically restarts the computer, which is safe because the instrument will just shut off and it won't lose control, or won't overcharge or discharge the battery. It'll just shut off and then wait for you to come back, and then you can restart the process from where it left off. So make sure that when you're reconditioning, so it's very important to keep your modules clamped and cooled. Okay, so we actually include the cooling box and the cooling fan with the instrument. Okay, so make sure you clamp the modules using the clamps or the rods that are that come with the pack. We had some people try to just use like a C clamp or other types of nuts and bolts that put the modules together, but when you're charging, right, these modules can swell, and if they do swell, it would pop those clamps off. So make sure you use these clamps. And this is actually an old version of the cooling box. The new version has this fan at the end blowing in and up. So what it does is it just blows air through in between the modules, similar to how the vehicle does it, to keep the modules cool. This new fan actually, because it's a little bigger, it's actually you get more airflow and it's less noisy. We used to have a smaller fan in here, but it was really, really noisy and people kind of complained about that, so we modified it. Some additional notes that you want to remember is that, so when you're reconditioning these modules and building packs, you also want to make sure that you clean all the connections, okay? Especially the bus bar connectors here. You can see they're made of copper, and you're getting some residue, corrosion on here. You can use CLR to clean them. You can use a like sandpaper or a drill with a drill brush on it. There's a number of ways. If you're doing a high volume, you can actually, some people just purchase these, so they get stamped at a metalworking or sheet metal facility. They can actually, if you give it to them, they can cut these out for you, and probably pretty cheap if you don't want to clean them, and you can just replace them. Okay, but make sure that these are clean, because again, this is all electrical, so these connections, if they're not clean, you'll get bad readings, and it won't actually know what the voltage and currents are properly. Okay. All right, so let's look at the software real quickly. There's a couple features. So you have the treatment plans over here on the left. We provide a lot of the treatment plans, and you can modify the treatment plan, so the user can edit them. But we have plans for all the types of vehicles, different voltages, and different capacity modules. Over on the right here, we have a real-time testing feature, which most people don't use, but what it does is when you connect all the modules, it'll just kind of show you the voltage readings, and you can manually charge and discharge the modules on your own. Like you can set it to 2 amps, hit discharge, and it'll just drop down. But most of the time, you're just running a pre-made treatment plan. Down here, you can see the data from the modules. We'll kind of go a little bit more into it later, but it provides you all the amp hour, watt hour, resistance, voltages, etc. Okay, any kind of questions on this? We're going to go into each of these a little more in the next few slides. All right, so with the treatment plans, again, so we kind of provide a manual for all the users too, but this is just kind of brief, where just to show you the features that it can do. You can make charge and discharge profiles. You can have different lines. As you can see right now, this project here has 8 steps. You can add an unlimited amount of steps. When I'm doing some research, I have like 100 steps sometimes. You can set the target capacity for the very last process, which is how you can change it to make 60 or 80% target when the whole process is over. Okay. You can set time limits, different cutoff voltages, different currents, but again, it's all preset in different plan files that we provide. Here we have the data processing. So this is what it looks like after the instrument is done running, right? After your modules the plan is completed, you get some data files, and when you open up the data files, this is the type of data you get. Once you kind of get here, you create a summary file for all of the modules, and then that's what you add to your inventory. Okay. So in order to run the instrument, it's pretty simple. This is kind of a brief showing. Is you just open the software, the EVc will be recognized, select your project file, you open it up, and then just press play where you want to save the files, and then you're done. Make sure the cooling fan is on, and it will run for 20 to 24 hours, depending on the state of the modules. Okay. So any questions on kind of how the EVc works and how it runs? And then I'm going to go briefly over how to kind of build a pack. We actually have 2 videos from one of our technicians on like showing him running the instrument. However, I tested it earlier and it doesn't work great while viewing in the webinar. It's a little choppy. So what I'm actually going to do is next week I will try to upload those videos to the website or onto YouTube and send everyone a link so you can actually view, the actual use of the instrument, being hands-on with it. Okay. So any questions so far? We're gonna now transition to part 4. Okay. All right. If there's no questions there, I need to hit this. Okay, so now we're starting part 4. And again, yeah, these parts are kind of more brief. Parts 1 and 2 were the main informational slides.
Hi, Jonathan. This is Mark again.
Hi, Mark. Yeah. Wait, hold on.
I got a question.
Hold on 1 second. I did something. Let me stop sharing screen and reshare this. Yes, go ahead.
Okay. During the charging, there's heat generation, correct? And that's why we have the cooling going. How much, apart from just having a fan installed, what other measures or what other infrastructure can one put in place to reduce the amount of heat that's been generated from the EVc machine during the charging?
Right. So one of the big ways that we have reduced the heat coming from, are you talking about from the modules, heating up the modules?
From the modules, yes.
We reduce the currents, right? So the thing is, we kind of modify and edit the plans every now and then, improve them. So I've been bringing the charging currents down somewhat. But in general, if you have it clamped and using the fan, nothing will happen. The only other time I've had modules, swell up to a large extent is in we had a user in Australia a while back, and it was like 120 degrees outside, and he had his modules running, being reconditioned in like a shed outside, and he didn't use the cooling box, and he just had like a floor fan, one of those spinning ones, pointed at it, and that's bad, right? So you want to use the cooling fan and keep it in an environment that's somewhat air conditioned and cooled. Also, with the instrument, you want to make sure the instrument is, it's expensive. It's basically kind of like a computer too. you don't want to have it outside or in a shed, or if you have a garage, if you're running in your garage, make sure it's in the back of the garage, possibly in its own room or in its own enclosure, right? You want to keep it clean.
Okay.
Okay, but yeah, if you want to, in order to prevent the swelling and heat, yeah, you definitely want to use a fan, and then you make sure you don't want to recondition the modules outside or anything.
All right. Thanks, man.
Yes. Any other questions with that? Okay, let me make sure this is running right, because it was being weird before. There we go. Okay. Yeah. So again, when you get the instrument, I provide a spreadsheet and all sorts of manuals on how to kind of do this, but we'll go over kind of the basics briefly. After reconditioning, you end up with the data files where you then export the summary file from it. Okay, and this right here is a summary file. It's actually just part of the summary file. You can see I cut it off right here, but what you get is the connection number, which is the channel that it's on. And each of these corresponds to a different module. You get the reconditioning date, watt hour or amp hour, watt hour, voltage, the average voltage, your resistances, the QR code, which the QR code, remember, it gives you the factory date. That's how we have this column here. So the software will read the QR code that you input and will give you the factory date. These two are kind of just IDs that tell you which instrument you're running on, in case you have multiple instruments, and kind of when you ran it. And then a user label is something that I recommend where, so the QR codes, if you look here, they're very long. They're important and they're good because they cannot be rubbed off. But if you have your own shop and you're only dealing with a couple thousand modules, possibly after a while, you could have your own user label where you just kind of mark the modules with a Sharpie or something. And it's a lot easier saying, yeah, I need to grab module 1000, module 225, and module 3 versus saying the QR code out. Okay. But once you have it in here, you kind of lock that label, the user label, in with that QR code, so you know which module you're referring to. Okay. And then you want to add your module data to your inventory. So here, these are kind of the different business models. And I kind of discussed this before, but you want to do the inventory. Okay. With the inventory, you can have quicker service where customer comes in with their vehicle. They've already given you all the information, and all you're really doing is switching their battery pack out and then putting in a reconditioned, balanced battery pack from your shop. Okay. If you have an inventory, you can have a more balanced amp hour spread, right? Because the more modules you have, the more likely you are to keep the amp hour spread low between modules in a pack. Because of that, you can then offer a longer warranty, and it is the full replacement of the battery pack. All right, but the one thing is that it requires management. You're going to need to, purchase some packs to start with, and then you're going to have to kind of keep that inventory spreadsheet that I had. The turnaround process is kind of something a lot of the original EVc owners did before, we were kind of growing and growing. The turnaround process, it just requires minimal inventory management. All you're doing is like taking someone's pack in, reconditioning it, and then putting it back in their vehicle. Okay. Obviously, that is longer service, right? Because if you take someone's pack out of their car, you recondition it, that takes 20, 24 hours, and then you need to put it in. So they're going to have to leave the car at your shop, or, you kind of figure something out with that. And again, that's shorter warranty because you can't really guarantee much unless you look at their values and know that their pack is balanced. Okay. So that process is, yeah, basically you're gonna create the summary file that we just showed. You're gonna add that summary file to your inventory, and you're gonna choose 28 modules for a Prius pack or 34 for a Camry based on amp hour, and then you're gonna need to order those modules as blocks within the pack to reduce the voltage. Okay. And once you do that, that pack is then ready to be installed. Some of the questions that people have is, if you have a bunch of modules sitting in your inventory for months, what should you do? And we actually provide plans where it's not a full reconditioning. It's simply a charge process where you connect those modules up and charge them, to 7.9 volts or so, and then you can install. Because leaving modules sitting on the shelf, they lose charge over time. So they self-discharge. But if you have modules sitting on the shelf for a couple weeks, they'll probably still be charged enough to be put into a pack and put directly into a vehicle. But once you kind of get past that, I would make sure that your module voltages are all high enough that they're not going to set off the check engine light immediately. Okay. So any kind of questions on the EVc? Okay. And
I have a question.
oh yes, go ahead.
Can you go to previous slide, please?
Yes. Yes.
Okay, in the inventory business model, if we store a lot of let's say modules, how much time they will be okay until let's say do not lose their charge?
I would say a few weeks. Because they.
Okay, so yeah.
Go ahead.
Yeah. What do you suggest a solution if I need to select this business model?
So yeah,
yeah.
So there's a couple ways. First, before we introduce the power tester, which I'll go over in a second, you would then so once you select all the modules in your pack, right? You'd say you have 28 modules, and they're from different cores, and they're from different times, right? Some are from a week ago, some are from 4 or 5 months ago. You put them all together. You would then connect it to the EVc, and I provide a plan where it just simply charges all the modules up. It takes about 30 minutes to an hour, but all it is a simple charge to a certain voltage, and then that's it. So you don't need to recondition them again, right? So the reconditioning process is done. You've regained that capacity. All you've done is that all the modules have done is discharge a little bit, right? They've been kind of sitting there and they're just losing charge, but you can recharge them using the EVc 30. One thing I want to note is that our EVd, which is the power tester and charger, it's similar to well, I'll describe that later, but you can use that to charge all of your modules up too. Okay.
Okay, thank you.
Okay. Any other questions like that? That's a good question though. Okay. So again, yeah, I'm going to go over the next presentation, which is simply the EVd, and then we will start our question and answer with Professor Smotkin, and I will bring him into the call. All right. So here, this is part 5. All right. So yeah, the power tester is something that we kind of just developed, but a lot of our users have been asking this for a while. And what the power test is, so a lot of times with EVc 30, right, most of the time you're just using low currents. So the charge and discharge, you're below 5 amps the entire time. What the power test does is it connects all of the modules, and you can see down down here. It connects all the modules in series, okay, similar to in the vehicle. You can see there's only one cable coming out. And it monitors the voltages under high current. Okay, and high current can be, I believe it's around 30 amps is what we use. And you only run it for 10 seconds or so. Okay, and what that does is it can kind of identify any faulty modules that possibly behaved correctly under low currents, but once you put it under a large discharge current, the voltage drops. Okay, so it can be used before and after reconditioning. So you can use it before if you want to, kind of like similar to the elimination process, remove modules before you recondition them, because a lot of users that kind of grow their business, they want to maximize the amount of module throughput. So if they know that a module is going to be bad, they can use that channel for a good module. So this is kind of a way similar to that elimination step. And the primary focus is to use it afterwards, though. After you build a pack, you would then connect it to the EVd40 and run the power test to make sure that none of the modules drop really low in voltage under 30 amps. Okay, the EVd40 accommodates up to 40 channels, but because it's built for packs, there's different vehicle harnesses available. Okay, so the Prius, the Camry, the 40 module packs, they're all going to require different harnesses. Okay, with the EVc30, that doesn't matter, right? Because each module is connected separately in parallel. But in this case, all of the modules are put into series and then discharged. Okay. An important thing with this pack too is that it includes a charging feature where there's constant current, okay, which means that you're charging at a constant current, and then there's also constant voltage, okay. And constant voltage, or CV, is how you charge lithium-ion batteries. And so this is kind of our beginning of venturing into the lithium-ion battery field. Okay, so constant voltage means you set it to, say, 202 volts, and the charger will start charging at 202, and when it approaches 202, it automatically reduces the current so that it hits 202 and doesn't go over. Okay. So yeah, it can charge lithium-ion batteries too. I'm going to show right here. This is an example of the EVd power test data. This right here is a Toyota Camry hybrid pack, and you can see that the voltage of these two modules drop rapidly as with time, right? And this is only, if you look down at the x-axis, this is only within 7 seconds. It gets all the way down here. So what you would do is then you can remove these modules and then kind of replace them. So it's another kind of step of quality control, because a lot of users before the EVd, they would put a pack within a vehicle, one of their test vehicles, and kind of drive around for 30 minutes to make sure that all of the modules are good. Okay, but that is kind of the purpose of the EVd. But again, it also charges too. Yeah, these are the specs of the device, and this is kind of the front panel. So you have the charger, you have the power. These are the voltage readers here that connect to either side of the pack. This is the discharge unit, and yeah, it also plugs into the computer, and that's how you get your data. So precondition screening, again, this is kind of review, but you can screen the incoming cores. Okay, what you do is you take the cores, you set them to charge to a preset voltage probably higher than 202 volts, and then you run the power test. When you run the power test, any weak modules will drop out. Okay, and you can run the same power test on assembled packs. Okay, very similar, where you can charge it and then do a sharp, high discharge for 10 seconds, and then identify if any modules drop out. Okay. Yeah, we developed this at the request of our EVc users because some users had other power testers, but other power testers didn't read module voltages. That's kind of the beauty of our EVD, is that it reads individual module voltages. Other instruments only read the blocks. So there's only 14 blocks, but if you have 28 modules, you want to look at each module, not the blocks. Okay, so yeah, we this is kind of a recent instrument, so a lot of our current users are have ordered it and are using it. So again, we develop and improve our software. They might want other features, but we listen to all the customers and get their feedback continuously. And I talk to someone probably every 2 or 3 days that has the instrument and has questions. So we're pretty good with that customer support. And yeah, that is the final. So that was part 5. So I'm gonna bring Professor Smotkin in right now. And
Jonathan,
yes.
can I have a question, please?
Yes.
Yeah, Jonathan, now from the explanation of the function of the EVD, I believe, I think also you just mentioned that the elimination process using EVc can replace this, isn't it?
So the EVc and EVD are different instruments, right? The EVc elimination process kind of measures the capacity, right? So it measures the capacity, if it can hold 2 amp hour or not. The EVD is special because sorry, let me stop back. In the EVc, it measures that 2 amp hour, but it only uses 1 or 2 amps. Okay. The EVD
correct
uses a 30 amp discharge. So that's the main difference. It can use the high discharge because some modules will drop in voltage when they're under a high discharge, but they behave correctly under a low discharge. Does that make sense? So it
is recommended to have is it recommended to use the EVD also beside the EVc?
Yes, the EVD it's recommended for the EVD to be used in conjunction with the EVc. Right. So the EVc is the main unit. That is the reconditioner. That is the one that gives you full diagnostics and reconditions the modules. Okay, provides you all the information. The EVD is to make sure it's kind of like quality control, right? It's a screener, and it's will allow you to run the power test, right? And that's a lot of people wanted a power tester. We tried to modify the EVc 30 to fit the power tester, but you can't based on the currents, right? Basically, the EVD is similar to trying to test it in a vehicle, if that makes sense.
Now, have you guys considered combining both so you can have it on one equipment?
Yeah, we have, but we really can't. They're very different instruments. Again, remember that the EVc connects every single module in parallel. And the currents are much lower than with the EVd. Yeah. So that's kind of why. Yeah. I mean, the EVd, we've been developing it for a little while, but we only have a few out there right now. But because a lot of people asked for that type of instrument, so we started developing that, and the EVd will run the power test. Yeah, they needed the power test. But combining them, yeah, it's something that would be ideal, but we have not gotten there yet. One second, please. I'm trying to get Professor Smotkin. I'm going to mute for 1 second. Oh, actually, it looks like he's joined. Hello, Gene. It seems like you are there. You can unmute. You're muted right now. So. In the meantime, does any other questions?
Hey, John, can you hear me?
Yes, hey, Gene. Yes.
Okay, so yes, I'm available if there's any questions or anything. This is Gene. I'm with Nuvant, and I work with John. I can't hear anything.
No, yeah, Gene, I'm here. I'm just waiting. Does anyone else have a question? I just answered a question about if we could combine the EVc and EVd into one instrument.
Actually, the EVc and the EVd, in theory, could be combined into one instrument, and in fact, it makes a lot of sense to do that. But the issue is that we develop our instrument development evolves over a period of time, and so there's quite a substantial capital investment that would be required, because we would have to revamp in part the existing EVc30 and then combine them. But actually, all of the features of a power test are actually in the EVc30 as it is. It's a matter of increasing the size of the power supply and changing the shunt resistors. So it could be done, but it would be expensive. And so that may be something that we do down the line if there are people that are interested in building very large facilities. It could be done on a custom basis. We actually built the EVd40 at the request of a customer that we have in New York, and so the answer is yes. In principle, they could be combined, and that's something that Nuvant could do. It's a matter of initial capital investment. Okay.
Other questions?
Yeah, the world seems to be going away from fossil fuel into purely, I guess, electric mode now because of concern about the environment. So what effect long term is the going away from fossil fuel going to have on this business plan? Because at least the vehicles for hybrids still uses gasoline. So basically I'm saying, what happens if everything goes into electric mode? What effect is that going to have on this business? Or is this going to be adjusted to accommodate purely electric down the road if it turns out that way?
Yeah, that's a good question. I think that we are going to move toward pure electric vehicles, but the timeline for that is going to be long term. I mean, the market share for electric vehicles like Nissan Leafs, Tesla, things like that, that market share is very small but growing, and it will continue to grow. In between are probably going to be things like plug-in hybrids. The plug-in hybrids, for example, are a hybrid vehicle. For example, the Chevy Volt, right? In Austin, Texas, a lot of the houses there that are rented all bills paid. And so there are a lot of people that had Chevy Volts, and what they did was you can drive a Chevy Volt hybrid vehicle without putting gas in it. And a lot of people in Texas do it. They have hybrids, but this is not like the Prius or the Toyota. This is a bigger battery. They actually drive around locally without ever putting gas in. That's for long distances, they put gas in. That's the Chevy Volt. Now, today, the nickel metal hydride batteries, they're on the tail end, okay? They are putting nickel metal hydride batteries in vehicles today. They're going into the 2020 RAVs and other vehicles, but we're imagining that that's going to tail down over the next few years. But the hybrid, the nickel metal hydride reconditioning business should be good for at least a decade after the last batteries are installed. So we're probably good with nickel metal hydride reconditioning for 10 more years. And then at that point, there will be an issue because eventually these nickel metal hydrides could phase out, well, they will, but it'll be a while. So in the meantime, our EVc 30 unit is very versatile. It's built with a very high-end data acquisition and control card that we use from National Instruments. Our instrument can acquire points at 500,000 points per second, meaning our instrument is upwardly mobile, and we are actually working now on the lithium-ion batteries. But that work is slow to go, and the reason we do need to shift to lithium-ion batteries on this type of equipment. Now, what hampers our progress is that you need a library of batteries. In other words, we had access to many nickel metal hydride batteries. So now, in order to really advance our recipes for lithium-ion, we need large libraries of Nissan Leaf batteries and even Tesla batteries. Once we have them, and the other thing is we need old ones. So it takes time for the degradation to occur. So the answer is that eventually, and I'm going to say 10 years or less, the nickel metal hydride business will tail down. And we believe that we have enough time in the interim so that by the time the nickel metal hydrides are tailing down, we will have an enormous head start over any other company in this area, because we're starting now to look at lithium ion, and we've actually found ways to mimic controlled voltage processes with our unit, even though it's a controlled current. And so we're working on it, and unit holders are always updated as to how things are moving along. So I hope that was a helpful answer.
Yeah, thank you.
Thank you. Are there any other questions?
Okay. And if you have questions or discussions that you would rather have offline, I will be available all day today, and John can let you know how you can get in touch with him or I for further discussions.
Yes. Okay.
Thank you, Jill. This is Dr. Arif.
Yes.
As we spoke at the beginning, we'll be very thankful if you send us by email this webinar, so it will be helpful to review it again and maybe come out with more questions.
Okay. Yeah.
Okay. Thank you, everyone. You'll be receiving an email probably on Monday or Tuesday, sometime next week, with more information, and I'll kind of keep everyone updated. You have all of my contact info currently. If you have any questions, just email me and I can put you in contact with Gene, or if I can answer the question too. But again, thank you very much, and I hope you enjoyed and learned a lot in the webinar. All right.
Okay.
Thank you.
All right.
Thank you very much.
Thank you.
Bye-bye.
Thank you very much.
Bye.
Thank you very much, Jonathan. Thanks, Gene.
Yep, you're welcome.
Thanks. Bye bye.